In this video, we're going to have a look at solving linear equations with an unknown variable on one side. So to solve a linear equation, we need to isolate the variable by itself on one side of the equation. We do this by doing a series of inverse operations to get rid of all the other operations that are currently on that same side. So the inverse operations are, so the inverse of adding a number is subtracting it. The inverse of subtracting a number is adding it. The inverse of multiplying a number is dividing it. The inverse of dividing is multiplying. The inverse of squaring a number is square rooting it. And the inverse of square rooting is squaring a number. So if we do these, we'll be able to isolate the unknown variable by itself and determine its value and solve the linear equation. So let's have a look at some examples. So we want to solve the following equations by doing the same to both sides. In my first example, it is 5b plus 3 is equal to 8. Now I want to get b by itself on the left-hand side. So to do that, I need to get rid of the other operations that are currently combining with b. So the first one I want to remove is my plus 3. To remove plus 3, I need to do the opposite, which is to minus 3. And what I do to the left-hand side, I also need to do to the right-hand side. So my equation then becomes 5b is equal to 8 minus 3. Then I still haven't got b by itself. At the moment, I'm multiplying b times 5. So to get b by itself, I need to divide 5b by 5. What I do to the left-hand side, I need to do to the right-hand side. So my expression then becomes b is equal to 5 divided by 5. So b is equal to 1. So by doing a series of inverse operations, I can determine that b is equal to 1. So let's have a look at my next example. 6d minus 4 is equal to 8. So again, I want to do a series of operations till I get d by itself on the left-hand side. Now the first operation I need to get rid of is the subtract 4. To do that, I need to do the opposite of subtract 4, which is to add 4. And what I do to the left-hand side, I also need to do to the right-hand side. So my equation that becomes 6d is equal to 8 plus 4. Since I still haven't got d by itself, I need to continue doing my inverse operations. So at the moment, it is 6 times d. So the opposite of multiplying by 6 is going to be divide by 6. And what I do to the left-hand side, I also need to do to the right-hand side. So that's going to become d is equal to 12 divided by 6. So d is equal to 2. These are examples where more than one inverse operation is required to get the unknown variable by itself and can determine its value. So let's have a look at another example. In this example, it is 8x divided by 5 is equal to 4. And I want to find out the value of x. So to do that, I need to first get rid of my divide by 5 on my left-hand side. To do that, I do the opposite, which is to multiply by 5. What I do to the left-hand side, I do to the right-hand side. So my equation that becomes 8x is equal to 4 times 5. I still haven't got x by itself because at the moment I am multiplying it by 8. So to get x on its own on the left-hand side, I need to divide by 8, which is the opposite of multiplying. What I do to the left-hand side, I also do to the right-hand side. So my equation that becomes x is equal to 20 divided by 8. So x is equal to 5 over 2.